This video we will introduce some conditional jump. If you remember, in the previous chapter, we talked about the jump JMP operation. When we use the JMP operation, that's unconditional jump. No matter what the situation, you just jump to a label. But actually, we have few more jump. Those jump, they are according to the status flag, so we call they are conditional jump. So we see what kind of jump we have. So when you're using different conditional jumps, they are based on your specific flag. So that's why we say the status flag. Then the equity. So this equity actually is kind of the same as the status flag, because when you compare two values, if the zero flag is set, we know they are equal to each other. So that's according to your equality, we have the jump. But remember, when we do the comparison for two registers, we will have the value because the register doesn't know the value they contain is signed or unsigned. So according to the value you consider, they will be unsigned integer. We have some unsigned comparison. The same thing if the register or the value you try to compare, they are considered as signed integer. So you have the sign comparison jump. So we will see all different jump. So the first thing we see the jump for the status flag. A conditional jump, like earlier we say, you will jump to a label if your condition are met. So that's why here the jump, we will show you the following jumps. They are according to your status flag. So we have JB and JC. So here the C, you will know that's the carry flag. So if your carry flag is set, so then you will using the JC to jump to a code label. Then that's a conditional jump. Also JB and JC, they are the same. So this B, you can consider they are below. So when you have your two values, they subtract each other. If the carry flag is set, that means it's not enough to subtract. So that's why here your JC and the JB, they kind of actually the same. They are according to your carry flag is set. So here I want you to remember, later we will introduce many different kind of jump. But many jump, they actually kind of the same condition. But we're using also still have this different name for the jump. The reason is the logic is according to how you realize the logic. So how you were using the jump. So the next one, JE and the JZ. E you can consider that's equity. So if compare two values, they are equal to each other. That means they subtract each other, they will be 0. So JE and JZ, they are similar. Actually, they are the same. They both because your 0 flag is set, so you can jump to a specific label. So then we have JS. So S is for the sign. So if your sign flag is set, so we can jump. So the next two is JNE and JNZ. So you will see it's not equal or not 0 flag is set. So these two jump, they are both in because your 0 flag is clear. And also we have our JECXZ. So this one you can see that's for the ECX. You can, according to your ECX value, you can jump to a label. So when ECX equal to 0, then you can use this jump. So the purpose for this video is show you all different kind of jump instruction. So when to use that, the application we will show you in the next video. So those conditional jump instruction, they are according to the status flag. If you remember before when we talked about the JMP jump instruction, remember jump must within -128 to +127 bytes from the current location. So that's the reason before I told you, supposedly we think since we are doing the 32-bit environment, So this restriction won't happen. But one thing is, I'm not sure why before few of you actually when you have your jump, if the offset still is more than or bigger than your negative 128 and the positive 127 bytes, they will still have problem. So we will keep watching this issue. So sometimes be careful about your code segment. So then if you want to do the jump, they will jump between the specific memory byte. So actually here is more jump. This table actually is earlier we show you all different kind of jump. So we're just using the table to show you. So that will be the same as earlier we show you. So the next one we will talk about some jump according to the equity. Okay, so your equality, why you can have the jump like the JE if they are equal to each other, if not equal, or your CX equal to 0 or ECX equal to 0. For us, we're using the 32-bit environment, so mostly we're using the ECX as a counter. So why you will do the equality jump? That's because, did you remember we show you an not destructive comparison instruction? So when we do the comp instruction, we try to compare two variables. About the comp instruction, you can go back to the slide 20 in this handout. Remember before we show you, we have some instruction, they won't change the operand value. So one is test, the other is comp. So the comp actually we will compare two values. So if they are two registers, so then they will just subtract the destination from the source operand, but your destination operand value won't change. So most of the time when you're using this comp operation, you want to know your destination operand and the source operand, which one is bigger, right? So according to the value is different, so you can jump to different location. So that's what we will do after the comparison instruction. So then the different jump according to your equality, they can use in the JE. So after you have your comp operation, so the left operand is your destination operand. So the right will be your source operand. So when we do the comp, we're using the destination operand subtract the source operand. So if they are equal, right, so then you see you do the JE. You jump to somewhere, so then you can continue to do that, to do some instruction. But also you have the JNE if they are not equal. So then they will jump to some specific location. So mostly your based on the equality is your previous instruction is your comp operation. So then you will see here, so the same thing again, according to your destination operand and your source operand, these two values, are they considered is signed integer or unsigned integer, right? So if you just don't consider, you only care about is equal or not equal, you can use the JE and JNE. They are the same, no matter you are doing the unsigned integer or signed integer. But when you consider maybe the destination operand is greater than the source operand, so then you need to consider, are you talking about signed integer or unsigned integer? So that's why here, after your comp operation, if those two values you consider they are unsigned integer, so then we have different comparison. So you have JA, that's mean above. So that's mean your left operand, your destination operand is greater than your right operand. So your JA actually equivalent to your JNBE. So not below and equal. That means above. So that's why you can say here is what I talked about earlier. A lot of time when we see those jump, actually they have this different jump name, but actually the content is the same. Like your JA and the JE, right? Your JA and the JNBE. Okay, so the same thing here. When you have your above or equal, so that means your left operand either greater or equal to your right operand. So this one actually equivalent to the JNB. So either one is fine, just your logic, which way is easier for you to do. So then you have your below, that's mean your destination, your left operand is smaller than your right operand. So that's below or not above. Okay, so then continue, you have your below and the equal. So that's not above. Okay, so you need to be careful. When you're using different jump, when we consider above or below, we are considered the unsigned integer. We treat the value as unsigned. So then you can do the conditional jump. But if you are jump based on your signed integer, so then we consider it's greater than or less than. So the same thing, your source operand, your left operand is greater than your right operand. You do the JG or J not less than. So then if your left operand is greater than or equal to, so you do the JGE or JNL. So if less than, okay, so they are the same. So less than or not greater equal. Okay, so the same thing, you have your less than and equal to your right operand. So that's for the sign comparison. So you have different kind of jump, and also you need to, according to the value you try to compare, they are signed or unsigned.